Hi, I thought that I'd go through some of these. I knew that this one was going to be hard for my students to see that this is an acid. So I also gave you that video to go along with it. All you need is just one thing to tell you what it is, and then you can figure out what all of them are. Because if this is an acid, then it's going to react with a base because they're all acid-base pairs. Okay, acid-base reactions. Here are the acid-base pairs. This species looks so much like this one. All it has is that it's just lost an H, and now it's got a negative because it lost a proton. Okay, these two species look a lot alike, so if this is an acid, this one's going to be a base, and since it's on the right side, it's going to be a conjugate base. That's neat because now you know this one here will be a conjugate acid. And hey, oops, I forgot a plus right here. It is also the hydronium ion, which is an acid, so that just supports your knowledge even more. And then, of course, these are acid-base pairs too. So once you figure out what one is, then it should help you out with all of it. Okay, now this one, like let's say you're thinking like, oh, I don't know if that's an acid. It's got a negative there. Yeah, it's got an H on the front, just not sure. Okay, this one right here, of course, we don't know which one that one is because it's amphoteric, so it could be either. Okay, but this one you do know. It is carbonic acid. Okay, it's an acid. And it's on the right side, so it's a conjugate acid. That means that this guy's a conjugate base, and you know that guy too. It is the ion for the base. Now you could be wondering, well, why is this negative? There is some other positive ion that's in there too. It's just not important. It could be a sodium ion. It could be anything. It could have been sodium hydroxide. And for some reason, in chemistry, they decide if it's not important, they're not going to write it. Sometimes they do. It's just not important. And they just make sure that's balanced. There's one negative on this side and one negative on this side. I digress. Let's go ahead and look at this again. Here's an acid, here's a base. It's on the right side, so they're conjugate acid, conjugate base. Okay, what species looks the same over here? It'd be paired with that one. So if this is a conjugate acid, this one's going to be the base. It's kind of neat because you know if this one's a base, this one will react as the acid. And hey, they're pairs, acid and base pairs. Okay, notice that they are acid and base over here and conjugate acid and base over here. Okay, now also think about this too. This one changed from lacking a proton to getting a proton. So it got a proton given to it. This one donated a proton to it. So this right here accepted a proton, so it is a base. This one gave up a proton to become OH. So it is a donor. So it's an acid, a proton donor. Just a reminder again that protons are H plus ions. Okay, let's look at this one. We know that this right here is nitric acid. That's how we've been writing them out this whole time. Well, if that's an acid, then that means that this one is a base. Okay, let's figure out our pairs. HNO3 pairs with, hey, this guy. Okay, so if that one's an acid, this one will be a base. It's a conjugate base because it's on the right side. Okay, it's just paired with it. Okay, if that one's a base, then hey, this one here is going to be an acid. And it is a conjugate. Well, let's make sure. Is it paired with this base over here? Yes, it is, because those are the same species. It's just lost an H, because that's what all these are about, whether they lost an H or gained an H, because that is the definition in Bronsted-Lowry. Proton donor, an H. Proton acceptor, an H. So I'm going to go through and I'm going to look at your assignments, and I will post this video on each one so that you can go through yours and do a little bit of self-learning with that. And I will see you later. Bye-bye.